Good morning, everyone. I'm James Chiang from APM. Thank you, organizer, to allow me to share something here. Basically, I will share two things. First is our view on Industry 4.0, and then second is our first initiative towards Industry 4.0. Okay, now we move on to slide number 2. Industry 4.0. I think Dr. Chua just now has explained very clearly what is this. Basically, I think during the Malaysia, they launched Industry Forward. I'm sure most of the people they are confused, including us, because Industry 4.0 is just too many things. Whatever you can think of also can be said is Industry 4.0. So basically here, for us, Industry 4.0, here also stated cyber physical system. I would say we believe it's more to information automation. Okay. It's not solely, but it's more to information automation. As for the previous revolution like first, second, and third electricity automations, is more to material automation, also called the process automation. Okay, where they are focusing on to automate, to convert the manual process into automation to improve the productivity. As you can see from the picture below here, okay, bottom left, is a typical production line. So you can see the part is conveying using the conveyor, okay, without human intervention, and then the process is handled by a robot. It's referring to material or so-called the process automation, where the facilities here get connected, and then the information can show in the dashboard here. We call information automation or the data automation. For example, the screen here, you can see the dashboard, the gripping force of the robot example. You can see the conveyor speed, whether healthy or not, and then the productivity, perhaps the OEE of the line can be visualized from here. Okay, so this is called information automation. For us, Industry 4.0 roadmap, first we believe we should achieve information automation first, because the information, the data that we collected later on only can be justified for subsequent facility upgrading. Okay, that referring to Industry 2.0 or 3.0. Ultimately, of course, everyone now they are talking Industry 5.0, like light out manufacturing. Okay, so in order to achieve information automation, there are a few steps we believe. The first, we need to get our facility connected. Okay, then we start to collect the meaningful data, actionable data. So the data that we can use, it's not every data we want to collect, those meaningful data to us. Then we visualize it to trigger when anomaly happen. Okay, then only we can analyze subsequently and automate it. Okay. So these are the few steps that we think we should do to achieve the information automation. So one thing to highlight here is also the talent development. For us, it's very important for the talent development, because this only way to make sense for more sustainable environment. We need to reskill our resources. We need to upskill our resources. Okay, we need to build the talent into the plant. Okay, like I think Dr. Chua just mentioned, the people first. That's more important. Okay, so we move on to slide 3. So just now I shared the roadmap. First, information automation first. Therefore, our first initiative, also called the hands-on proof of concept (POC), okay, is to get the data to get our facility connected. Okay, which referring to the title here, the data generation through neural programming and IoT methodology. Okay, thanks to HLRDC team also, because this is a project that we collaborate with them. Okay, last year, we focusing on one of our line, final line, SMB. The project happened last year, May to July. Of course, subsequently, we get all these things live in October. Okay, basically, we learn how to use the programming, the neural and IoT methodology to collect the data for OEE, to visualize, to realize the connect, collect, and visualize. Okay. At the same time, we reskill our AMS Kaizen team. AMS here is meaning APM manufacturing system. We have our own system within the group, okay, towards Industry 4.0. Okay. So we look at the general structure approach here. As you can see, This is our typical line. And then we have our tower light here, okay, with different colors that represent different downtime to the line. Okay. Then we connect the line, the machine from the sensors or relay and go into the IoT gateway. In this case, we use a Gunbus Revolution Pi. Okay. Of course, we also use a PLC to do the interlock for the tower light here. So all the signal collected will be stored in the Gunbus Revolution Pi. Okay. By the way, at this moment, we are collecting a digital signal, meaning 1 or 0, on or off. So analog signal will be our next stage. Okay. So after collecting the data to the IoT gateway, then the information will channel to the PC here by using the MQTT. Okay. Then the neural programming we use to do the programming to do all the calculation. Okay. Then eventually the data to be stored into the InfluxDB subsequently can be collected and visualized by using the Grafana. It's a dashboard software that we can visualize all the data that we collected. Okay. So all the calculations, the OE, availability, everything will be done by using the neural programming. Okay. Visualization only by the Grafana. So this is a very simple project. Then we can realize, connect, collect, and visualize. Okay. So to be exact, this is our dashboard now. Okay, as you can see, the dashboard, we have availability here. Okay, and then the performance, we can know the how fast the line is, the actual cycle time versus the target, and then the quality, OEE, and then operation rate as well. Okay, at the same time, we can visualize our current productivity, output in actual versus the target, the cycle time versus the target cycle time. Okay, so the graph here can show the trend of the line, and then we also can show the trend of the productivity here. Okay, so here we can see the total downtime of the line as per now, and then we also can know every single downtime. For example, the downtime due to quality, downtime due to machine breakdown, supply, changeover, and others. Okay. Other than that, we also built in the information for our Jitoka point. For those company implement lean manufacturing, you know the JIT and Jitoka. Basically, Jitoka is the parameters that is important to make sure the machine produce a good part. Okay. So in this case, we also built in the Jitoka point here. Example, like one of our welding machine. Okay. The water supply, is it okay or not? The inverter, the pressure, the welding, and then the overlapping. Okay. If any of the point NG, then the signal email will send to the related PSC. Okay. So the next, to answer the question, can our legacy machine get connected for Industry 4.0? I think this question always be asking since day one. So we all very worried that not all our machine is new. Okay, some machine is legacy. So can we get our machine connected or not? So as per the example just now I shared to you, basically I would say yes, possible we can get the legacy machine get connected because we gone through before. Okay, and then in additional to that, I think Bosch. Now we at slide 6. So I think Bosch has shown very good example earlier. So they take out one machine, they so-called the antique machine. To be exact, it's a cast iron workbench. They used to wind coil for starter motor. So, and then in year 2017, they take out the machine and then they turn the machine into Industry 4.0 ready. So the machine now, they can track in real time the RPM for the motor, and they also can track real time the condition of the aging ladder drive. Okay. So once again, show that legacy machine we can easily get connected to get the data the data that we want. Okay. I think that's all from my side. Thank you.